So, hello and welcome to all my young friends who are studying in intermediate and they are watching this video. Welcome to the lectures of GTK Academy. In our previous video, we had discussed work, power, and energy. I hope that you would have seen that video. If you have not seen it, please do see that because that's a very, very important topic of mechanics. Today, we are going to discuss the next topic, that is center of mass, which is again very important topic, although it's quite easy, and the problems which are asked in competitive exams which we are going to discuss, they are quite easy, so there is a lot of scope for scoring good marks. So from that point of view also, this chapter is very important. So let's start our topic of today, that is center of mass. Now, if you just see here, I have written the spelling of center as C-E-N-T-R-E. Normally, we write C-E-N-T-E-R. Some people may get confused, but they are both the same thing. This is C-E-N-T-E-R is American way of writing, and this is the British way of writing. Now, since in most of the books they have written center as C-E-N-T-R-E, so that is the reason I have written the same spelling here, and I have discussed and tried to clear the doubt which some of the people may have. Now, what is center of mass? As per the definition, center of mass is the point about which the entire mass of the system is equally distributed. That is a point about which the entire mass of the system is equally distributed. The system can be a body, or it can be, we can consider number of particles as a system. Now, let us assume that center of mass for a body, which is shown in figure below, is C. So this is the center of mass of this body. So that means the mass, whatever the mass of the body, it is equally distributed around C. And the other very important thing is that entire mass is assumed to be concentrated at this point C. Suppose the mass of this body is M. Now M is the mass of the entire body, but we assume that whole mass is concentrated here, as if there is a small body of mass M at center of mass. I have shown center of mass in yellow color. Normally it's a point, but I have shown it big just for you to understand. So we assume that the whole mass of the body is concentrated at this point, which we term as center of mass. Now, when the system moves under external force, this point, that is center of mass, moves as if the entire mass of the system were concentrated at this point. That means, suppose this is the body and this is the center of mass, and there is a external force applied to this body and it moves like this. So we can consider, instead of the movement of the whole body, we can consider as center of mass moving and the mass being concentrated at this point. That means the movement of body can be considered as that of its center of mass. Instead of the movement of whole body, you can also consider the movement of its center of mass, assuming that the whole mass is concentrated at this point C. That means motion of center of mass describes the motion of the whole system, be it a body, or a collection of particles. Now, before we proceed further on this topic, let's revisit some concept of vectors. I hope that many of you may be knowing it, but still I am going to discuss because we'll be using this in our derivation in the coming slide. Suppose this is a point A and this is a point B and this is a point O, and OA is OA vector and this is OB vector, and just join AB, and we have a point C on AB, and this is OC vector. Now the point C divides AB in the ratio of M is to N. This is M and the other one is N. Then OC vector, that is this vector, is equal to N into OA vector. Please note this, N into OA vector plus M into OB vector, M into OB vector upon M plus N. I think many of you may be knowing it, but anyway, I'm going to derive it. Now, if this is O and this is C, this is A, so OC vector, which is that is equal to OA vector plus AC vector. OA vector plus AC vector. So we'll write it OC vector is equal to OA vector plus AC vector. That means AC vector is equal to OC vector minus OA vector. Similarly, this BC vector is equal to OC vector minus OB vector. Now we know that AC vector is equal to, we write it in terms of AB vector. You just divide AB vector by A plus B, sorry, M plus N, and multiply by M. This one. So this will be your AC vector, and BC vector similarly will be equal to N BA vector upon M plus N. So now we'll substitute the value of AC and BC in terms of AB and BA. That means M AB vector upon M plus N is equal to OC vector minus OA vector. That means AB vector will be equal to M plus N upon M OC vector minus OA vector. Similarly, BA vector from this equation, when we write BC in terms of BA, that will be equal to M plus N upon N OC vector minus OB vector. Now this is your equation 1 and this is your equation 2. When we add 1 and 2 on the left hand side, it will be AB vector plus BA vector. They are equal and opposite. That will be 0. That means 0 is equal to, now you can take M plus N as common and just strike it out. 1 upon m OC vector minus OA vector plus 1 upon n OC vector minus OB vector. Now take OA and OB on other side and take OC common here. OC vector mn upon m plus n is equal to n into OA vector plus m into OB vector upon m into n. This gets cancelled. That means OC vector is equal to n OA vector plus m OB vector upon m plus n. So this is a very standard result, and if you don't know it, please remember this, and we are going to use it here. I hope it is clear to all of you. So once again, I'll write it. OC vector is equal to n OA vector n into OA vector plus m into OB vector, the vector on the other side, upon m plus n. Now, what we had discussed about center of mass few slides back, it is a point about which the entire mass of the system is equally distributed. Suppose we have 2 point masses at A and B, both m, having mass m. Now, can you tell me what will be the center of mass in this case if I ask you? Without any doubt, everybody will tell me that it will be the middle point, that center of mass C will be the middle point, and C will divide AB in the ratio of 1:1. Actually, it is m:m, which is equal to 1:1. Now, if instead of both mass being m, if we have one mass as 1 and other as 4, then the center of mass is going to divide AB in the ratio of 1:4, but 1 will be this side and 4 will be this side, because the logic also says the center of mass is going to shift towards the heavier one. Now, if we have masses m1 and m2 and C as their center of mass, now C will divide AB in the ratio of this portion will be m1 and this will be m2. I hope this is clear to you all. Now, let's start with two particle system, the center of mass of two particle system. We are going to make one statement that the product of total mass of the system and the position vector of the center of mass of this two particle system, this is equal to sum of product of masses, individual masses of two particles, and their respective position vectors. So what do we mean by that? Let me clarify by the figure. Say we have mass m1 at A and mass m2 at B, and this is our coordinate axis. Now, let's say the position vector of m1 is r1 and that of m2 is r2. Now, if C is their center of mass, let the position vector of center of mass be r cm. We denote it by rcm. Now what we are telling? We are telling that the product of total mass of the system, that is m1 plus m2, into the position vector of the center of mass. What is that? rcm. That is equal to the sum of product of masses of two particles and their respective position vector, that is m1 and its position vector is r1 plus m2 and its position vector is r2. Now let us derive this. Now we have already discussed just now that if C is the center of mass of m1 and m2, this is going to be m1 and this is going to be m2. That means what will be OC vector? We just discussed OC vector will be m1 into OA vector, m1 into OA vector plus m2 into OB vector upon m1 plus m2. Now OC vector is rcm. That is equal to m1 into, now OA vector is r1 vector plus m2, OB vector is r2 vector upon m1 plus m2. That means, now take m1 plus m2 on the left side, m1 plus m2 into position vector of center of mass, that is equal to m1 r1 plus m2 r2. That is what we made the statement here. So this is a very, very important result and you should remember this by heart, and it's very, very easy to remember also. I hope this is clear to you. Now coming to the same example, if we have this masses m1 and m2 moving with velocity v1 and v2, and we consider m1 and m2 as a system. Now we are making one more statement which says that motion of the system can be studied as motion of individual particles or motion of total mass placed at its center of mass. That means either we study the motion of m1 and m2 as individual particles, or we can study the motion of center of mass assuming that the whole mass is placed at this point C. Now since they are moving with some velocities, now force on m1. Now force on m1 will be F1, we denote it by F1, the external force, plus F12. If this is a system, force on 1 due to 2. So this will be equal to, this is the net force on m1. Net force. This will be equal to m1. Now force is equal to mass into acceleration of 1. Similarly, force on m2 is equal to F2, that external force on 2, plus F21, force on 2 due to 1. That will be equal to m2 a2. Just add both of them. So F1 plus F2 plus F12 plus F21 is equal to M1 A1 plus M2 A2. Now F1 plus F2, we can call it as F external. These are external forces. And F12 plus F21, this is your internal force. And this is equal to 0 because internal forces are equal and opposite and their net result is 0. So we can write here that F external is equal to M1 A1 plus M2 A2. Now we know that A1 vector is equal to d by dt of V1 vector, and this is equal to d by dt. Now V1 vector is d by dt of R1 vector. So that is equal to d2 by dt square of R1 vector. So F external will be equal to M1 d2 by dt square R1 vector plus M2 d2 by dt square of R2 vector. Now you can take d2 by dt square outside M1 R1 vector plus M2 R2 vector. Now we know that M1 R1 vector plus M2 R2 vector is M1 plus M2 position vector of center of mass. So our external force is equal to d2 upon dt square of M1 plus M2 into position vector of center of mass, which is equal to M1 plus M2 into d2 upon dt square of position vector of center of mass. Now this is acceleration of center of mass. So that is M1 plus M2 acceleration of center of mass. So we can write now that F external force is either equal to M1 A1 plus M2 A2, and this is also equal to M1 plus M2 into acceleration of center of mass. So either we study individual particles, the motion of individual particles, or the motion of center of mass, assuming that the whole mass is placed at this point C. I hope you have understood this. So we have discussed the center of mass for two particles, for a system of two particles. Now let us try to find out the center of mass for system of three particles. Suppose we have M1, M2 and M3, three particles, and the position vector of M1, M2 and M3 with respect to uh, a reference origin as R1, R2 and R3. Now, how do we do that? So what we'll do initially, we'll find the center of mass for M1 and M2. Say it is C dash and the position vector of C dash is R dash. So we have already discussed that if C dash is the center of mass of M1 and M2, this will be M1 and this will be M2. That is, C dash will divide this line in this ratio M2 is to M1. Now R dash, that is the position vector of C dash, will be equal to M1 into R1 vector plus M2 into R2 vector upon M1 plus M2. Now we have found C dash, so we'll consider the whole mass of M1 and M2 to be at C dash and we'll remove them. So now we are assuming that this mass of M1 and M2 is at C dash, and we know R dash we have already found. Now what we'll do, we will find out the center of mass of M1 plus M2, that is, and M3. So just join C dash and the point where M3 is placed. Now if C is the center of mass here and RCM vector is the position vector of center of mass, so this will divide this line in the ratio of M1 plus M2 and M3. Now position vector of center of mass will be equal to M1 plus M2, this into R dash vector plus M3 into R3 vector upon M1 plus M2 plus M3. Now we know what is R dash. So here we'll substitute the value of R dash from here. So this M1 plus M2 will get cancelled. So position of center of mass, finally, that will be M1 R1 plus M2 R2, because M1 plus M2 will get cancelled in the denominator, plus M3 R3 upon M1 plus M2 plus M3. So this is the position vector of center of mass for three particle system. Now instead of 3, if we have n number of particles M1, M2, M3 till Mn, we can easily prove that if C is the center of mass of this system and RCM vector is the position vector of center of mass, RCM will be equal to M1 R1 plus M2 R2 and so on till Mn Rn upon M1 plus m2 and so on till mn. Or we can also write this is equal to sigma m1 r1 upon sigma m1. So this is the position vector of center of mass. One important result. Now, if the coordinates of C are